This is the Amp Hour Podcast, recorded April 29th, 2012. Episode 93, with guest Tom Laments, Cacaesthestic, Chronometric, Carriwitchet.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
And I'm Tom Laments, joining from the depths of the automotive industry.
The bowels of the automotive industry.
The bowels, sorry.
Also known as Detroit.
Detroit. Or near Detroit. Is this something that you want to differentiate yourself from right up front?
Oh, it's not necessary to really go into a lot of depths about differentiating. It's sort of Detroit's kind of like this donut, right? It's sort of a kind of a really complicated inside core and not really so populated. And then you move out just a few miles and suddenly you're in just about any other metropolitan area of the United States.
Right.
Yeah. That's like Cleveland too. I mean, Cleveland and Detroit are not surprisingly quite similar. So another Midwestern brother here. So Tom, we welcome you. We welcome you to the Amp Hour.
I'm outgunned again. I'm going to have to get an Aussie on the show, really.
Yeah, at some point, yeah. Well, we've had a couple. We've had Alan at least, right? I mean.
Oh, yeah, true. Yes, we have had Alan, and we're probably going to have Alan on again. So,
yeah, we'll have to have some other Aussies to make you feel better, huh?
Absolutely. Now, is it true, Tom, that is it like in Cleveland, you can buy the house for the price of a VCR? Is that is that true? I've got to ask.
People are buying VCRs these days so often, right?
A what?
Yeah, exactly. Betamax, what?
That's about right.
Laserdisc.
That's about right. But just like that VCR, you probably wouldn't want to live in it either. I mean, it's...
right. Yeah,
but yeah, absolutely. Yeah, if you're, in fact, there's a lot of real estate speculation going on right now in the Detroit area with people really just gobbling up properties left and right, and it's kind of become a problem because then the property owners don't actually live anywhere near there, so they're not really taking care of it.
Exactly, and it runs down. Yep. But it will almost start a chain reaction of the prices going up because of the speculators. That's what speculating does to the market, really. So it can artificially bump it up for good or bad, but that's the effect it can have.
Well, haven't seen that one yet, but
right, okay.
Eventually,
maybe
keep
it doesn't work. Yeah,
I don't think I'm moving anytime soon. That's
is Detroit coming back in terms of getting its automotive industry back and getting jobs back? Can you see things picking up?
Well, so it's definitely picking up, and here's where you kind of have to really differentiate between Detroit and then just the whole southeastern Michigan. So, Detroit proper's got they just fell under 1 million people a few years ago, which really made them angry.
What was the peak?
Oh, God.
How many? Yeah, was it 10 million or, is it?
No, I don't know. It was never that big, but I mean, I'm guessing it was at least double that. I mean, I'm remiss. I didn't study up, but
it's like you're here to talk about electronics or something.
Yeah, exactly. I just I'm just fascinated by the whole Detroit thing.
But the
whole, because it's a shame, really.
Oh yeah, it's and honestly, so I've lived in the Detroit area. With the exception of when I was at university, all my life. So it's just been this kind of. So is it coming back? Yeah, it's been coming back since 1980. But it's kind of like
it's got a long way to go.
It's got
right?
a long way to go.
Yeah.
But the whole southeastern Michigan area, it's like 4.5 million people or something like that. So like I said, it's kind of the donut effect, right? And
and it's quite spread out too, just like Cleveland is. I mean, it's very
that's the
lot of suburbs.
Same here in Sydney. We got 4 million people in Sydney or something, but they're spread out around a 50 kilometre. About 30 mile radius. So
thank you, Dave.
Yeah.
Yeah, so
or half radius, I should say, because the other half is ocean. So
okay, then it's a lot like Detroit because our other half is Canada. So right.
Okay.
So Tom, tell us more about your background. I mean, you kind of touched on college a little bit, but where did you come from? You know, what have you done in the past, and where are you going in the automotive side of things?
Sure. So, I guess I've been an electronics nerd since about age 7 or something like that. That was back in
excellent
1974, and
we don't judge here. We don't judge.
Feeling kind of creaky. I remember buying my first LED at Radio Shack, right, and just going home and watching it glow, until I killed it or something. Right? It's like
and you went there and bought your 2 resistors in the packet, right?
Exactly.
Yeah. Off there,
for 39 cents or whatever.
Which you can still do for many years. I mean,
you can do that here again from J-Car here in Australia. They actually sell I think it's 5 or 10 resistors in the cardboard pack, the old fashioned. Yeah.
Yep.
Wow, it's coming back.
Exactly. Ooh.
Yay.
Yeah, your 5-leaded quarter resistors, right? It's
that's it
times.
for $1. Yeah. It's great. Inflation and all.
Yeah, now it's probably $1 or something like that.
Yeah.
And so like I said, I kind of stuck around in the Midwest. I went to school at Michigan State University, so I got my bachelor's EE there. And while I was in school, I earned bar money by had a job there outside of school, kind of designing and constructing analog sound and audio equipment for a psychoacoustics professor because he had cool experiments to do about human sound perception and stuff like that. So
I was going to say, was he just an acoustics professor who was crazy, or was he actually about the mind and how it perceives audio? Because that it could have been either, really.
I mean, he was in the physics department, so there's for sure there's a little bit of crazy there. I mean, just kind of
right,
but not psycho acoustics.
That's probably
right?
Good, yeah.
Right.
So in case he's listening, sorry, he's not he's not psycho, but it was really cool. I mean, honestly, that was and he had a really good electronics background, anyhow. So I mean, it was and I didn't know anything about psychoacoustics, so it was fun. It was a good. It was a great job to do while a student, and then later on in college, I actually got to work on some instrumentation for the Fermilab particle accelerator.
Whoa,
yeah. Excellent,
nice. Yeah, nice. So my
that's out in Chicago, right?
Well, yeah, it was. I think they just buried part of it or whatever. Yeah.
Oh, really?
Yeah. Well, I guess they can't really bury it because it's radioactive and stuff. So, you know what? Sorry, I heard they turned it into a museum, right? So if you can't dispose of it properly, you open it to the public, right?
Exactly.
Yeah. Let's all go hang out there.
Let them in and charge them admission to come and get irradiated. Brilliant.
Admission's $1. Lead underwear is $10.
That was kind of cool. Yeah, because that stuff actually that I worked on helped find the top quark back in '95. So
wow,
yeah,
that's cool.
And I got the board just earlier this year. The one of the really cool guys that I worked with there said, "Hey, you want a piece of history?" I said, "Sure." He's like, "Here you go." And it's huge. These boards were just racks and racks of these things, and they're 9U, right? So a U was yeah.
That's big.
So it's 9U on a side, so it's
wow.
Yeah, and it's full, and it's chock full of 10K and 100K ECL stuff.
Yep.
Right? That was that was
with nice big gold caps on them.
Oh yeah.
Yeah, all those those nice ceramic packages with the big gold caps. Yep.
Tom, do you have pictures of that? Maybe we can post those later.
You know what? I'll take a picture and send it to you. Yeah.
Nice.
Yeah, that was that was a lot of fun. Yeah, I mean, it's just ridiculous. Each package was it's like a 16-pin ceramic dip or whatever, and each package just dissipates about half a watt, and it's got 3 NOR gates in it or something.
That's right.
It's just incredible,
and back then you were probably like, "Oh, this is awesome."
Oh, it was the whip. Yeah, for sure.
So modern.
Yeah. Yeah, that was 200 megahertz, baby.
Yeah. Whoa, that was quick back then.
Yeah, actually it was. Yeah. So
that was screaming along. Especially when you've got to get it from one side of the frickin' rack to the other. That's pretty. You know, that's an art in itself, let alone actually from one side of the board to the other at 200 megahertz with all this digital, you know. It would have been working at, you know, at not, you know, low voltages like we're used to these days. So, you know.
Right.
What, that's swinging 10 volts kind of thing, or what?
Well, the ECL was kind of neat because, I mean, ECL is sort of, I look at it, it's the way an analog guy would do digital logic, right?
Oh, okay.
And so, I mean, for one thing, it was kind of weird that you had ground and then a negative 5-volt power supply.
Yeah.
Go figure. Okay. And then, but really the logic swing was only a few hundred millivolts. It was maybe 400 or 500 millivolts. And everything was differential.
Yep.
So, quite honestly, it's sort of like the 20-year precursor to LVDS or something like that, right?
Yeah, okay. True. Yes, and it's still people still use ECL, I think, today. There's still a few obscure retro applications. People still use it, I think.
God, do they really? Oh, that's sad.
Well, they maybe have to interface with, you know, old stuff. So you can still buy ECL to, you know, LVDL, you know, converters and stuff like that, I think.
Yeah, you're right. Actually, they made really good, the ECL, they made really nice line drivers.
Yep.
Right? For that reason, yeah. And so, yeah, crazy stuff. So, yeah, that was that was cool. And then was all ready to go work for a now defunct computer company on the East Coast that made mini computers. And I was like, oh, that'll be great because I was all computer architecture guy and high speed digital.
Right.
And so this was 1990, and found really
mini
kind of
computers in 1990.
Mini computers, yeah, exactly. Big iron.
Can you guys explain this to me? I'm sorry, I'm just out in the cold.
Right.
You guys are laughing. I'm sorry. Young guy, I'm going to raise my hand. Sorry. Little help.
Mini computers came along before microcomputers.
Okay.
As in, a
bigger.
microcomputer, you know, is a consumer desktop computer. Mini computers.
Oh, so these were like the ones that were like
floor standing
cabinets,
you know, and
right.
Yeah.
And it was going to modernize the home, that kind of thing.
Exactly.
Put out in the garage, heat it in the winter, kind of thing.
The mini computer companies didn't care about your home.
No,
exactly.
Yeah, whatever. And in fact, that was their downfall, right?
Okay.
Yes, they didn't see the consumer computer revolution coming, and they.
Oh, so was it
died.
mini, micro, personal? Is that kind of how the progression went?
Yeah. The microcomputer is the personal computer.
Oh, right.
So that's
then it was mainframe.
Well, there's mainframe, which they still do mainframe.
That was the top of the scale, you know. Right.
So technically they still make mainframe computers these days. They're the big racks of, you know, IBM still make these huge, and other companies, Cray and companies make these huge, you know, rack-based computers, but they're all Intel.
Not anymore.
You know,
Cray got bought by Intel.
Sorry?
Cray got bought by Intel.
Yeah.
Oh, when?
I think last week.
Ooh.
Oh, really?
Yeah. Just recently. Yeah.
Oh, okay. There you go.
Look at that, working news in with talking to Tom.
Well
That's pretty good, right, Tom?
Up to the minute.
Yeah. This was not recorded 3 weeks ago.
Right, yeah, that's the official date.
Yeah,
here, right?
Exactly.
Please, Chris, tell us that you've heard of, like, the PDP-11 and ones.
Yeah.
Right, they're mini computers, you know?
Okay.
Yep.
So, Tom, it didn't work out with these so-called mini computers?
Well,
he was smart enough not to join, weren't you?
Well, no. I honestly, I think it was kind of being lucky, right? That they sort of imploded about a few months before I graduated. That there was a for sale sign on the lawn out at Digital in Boston, and it's like, so that's probably not where I'm going to head off to then.
Right.
And like, and then of course it was, oh shit, I got to find a job,
right?
And then ended up because I tried to get out of Detroit, and then but actually ended up working for this small company that made car alarms, right? So
the car alarms were big in the 80s and still into the 90s, weren't they?
Yep.
Yeah.
Okay, so this is 1990.
They're gone now. Yeah,
they're pretty much gone now. Yeah, the automation finally said, yeah, we'll do that, and then that pretty much sank.
That was the end of that, right?
That was pretty much the end of that. Yeah.
Yeah.
But,
actually, most new cars I've seen don't have car alarms. They don't here.
Really?
In Australia, yeah, new one, because people just ignored car alarms when they went off. They were just ignoring, you know.
So much crime.
Yeah, well, no, because they were just annoying, you know. Because they'd go
thought Detroit was bad, folks.
Right? No, like we bought a new car. You know, it's a Japanese car, and it doesn't have a car alarm. You know, my car doesn't have a car alarm. It's only 10 years old, you know. None of them have car alarms. Everyone I looked at didn't. You know, like they've got these engine kill immobilizer things, you know. But the fact that, you know, to actually have a car alarm with the motion sensors and the, you know, all that sort of stuff, no. Certainly not here.
Yeah, you're absolutely right, Dave, that it kind of morphed into the whole, you know, look, the, you know, what really drove this was like, you know, there was like the car insurance lobbies, right? And for the most part, they were just mad having to pay out claims for people's cars that got stolen, right? Yeah. So they said, you know, so it's like, look, I don't care if the thing beeps and drives everybody crazy. I just don't want it to get, you know, don't let them drive it away. So so it turned into the whole engine kill, or the immobilizer and all this other stuff. And you're absolutely right that even back in the 90s, the car alarms were sort of like, oh God, you know, someone's damn horn's going off again.
Wah, 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 you know.
And then there was a club too. I mean, that must have put you guys out of business too, right?
The club. No, honestly, the club company was owned by one of the car alarm companies. So.
Nice. Yeah. Smart.
There were probably like 6 or 7 companies, and even in the course of about 3 or 4 years, they all kind of bought each other and kind of, you know, amalgamated or whatever.
As a very bright burning flame that quickly went out, huh?
Exactly.
It sounds like the component supply industry. You know, all these component supply, they all buy each other out and morph and merge and do all sorts of things. Change their names for the 10th time, and
exactly. try to hide stuff. But that honestly, for me, that was a great job because it was a small company, so you wore about 100 hats, right? And so, you know, like I said, I had kind of this high-speed digital you know, background, and there's this, like, it's microcontroller stuff. It's 68 HC05, and it's like, okay, you know, you know, but I always liked assembly language. I've been doing that for ages. It's like, okay, that's fun. That's good. That's good stuff. And then one day the owner, you know, kind of walked to my office, and so the RF receiver for these car alarms was always in this little daughter board. And it's kind of like a 2-inch by 1-inch, let's say, kind of little sub-assembly, right? Okay. And then he kind of threw it on my desk, and he said, fix this. I was like, huh? And because the guy who touched it last quit like 6 months prior, and it's like, you know, they were building them for a while, and then it's like, hey, these aren't really working anymore. And so that was my sink or swim introduction to RF.
Wow.
And honestly, it was a trip because this was all still like these are all still through-hole components. And RF with through-hole components just sucks. It's just, I mean...
everything's an antenna, right?
Yeah. Well, everything's an antenna, and just, I mean, literally the receiver that the guy threw on my desk, there were, you know, there were TO92 transistors that had to be bent at like a 30-degree angle. There was like a little jig in the factory.
Oh, really?
Because, oh my God, if you bend it at 22 or, you know, 45, it's not going to work. And
oh, no.
Oh, yeah, it was just a total disaster, yeah. And so,
wow,
yeah, so I was like, oh, okay, fine, and it actually was a cool circuit. It was I don't know if you've ever heard of it. It's called the super regenerative receiver.
Yep,
super regen, and so it's in my mind it stands as just a really awesome, and it was kind of also my introduction into vintage electronics. So this is a circuit dating back from like, God, I want to say it's like 1917 or 1919.
I was going to say, when was the first super regenerative receiver? You know what I'm talking about?
Yeah, super regen. Yeah, right.
Yeah,
yeah. That's
it's
why
easier
I
to
say
shorten the word. Yeah,
and that's all based on like just like a lot of the radio transmission stuff. That's where it all came from, right? I mean, the super regen was
one
a big
of the big radio, you know, inventions. Was the super regen receiver? It was one of the, you know, huge inventions of the probably what 20s.
Yeah, actually, yeah, maybe? You're right. It's probably like 22 or something. You know, actually, I've got the paper on. I've got the PDF. So this is from Armstrong. You know, Edwin Armstrong, who also invented the super heterodyne receiver as well. So, pretty cool guy. And I've actually got the PDF of the paper from 1920 or whatever that I'll send that along to you as well, so you can
send along. We'd love to link that in.
But But why that circuit's so cool is just because it's basically with one active device. So then it was a tube, and then later on it's a transistor. But with one active device, it's a complete receiver with actual gain. I mean, and it was this crazy idea where it's an amplifier that's just on the brink of oscillation at the RF carrier frequency. So it's about 315 megahertz here in the US is kind of the normal remote control car alarm frequency thing. And so it's this amplifier, and it's going to oscillate. It's going to oscillate in the matter of like a few hundred microseconds or something like that. And then as soon as it oscillates, it draws more. It draws a different amount of current. The bias point shifts, and you put this other little kooky feedback circuit in it to kind of thwack it again, and then it stops oscillating.
Just keep it under control.
Right? Yeah. Then it kind of starts all over again.
Yeah,
and so
it's this teeter-totter arrangement. I'm using the US term there.
Teeter-totter, yeah, exactly.
See?
And
versus
seesaw, right?
Yeah.
Oh, okay.
And then and then what happens is then when so you get this oscillator that kind of like starts up and shuts down in every few hundred microseconds or something like that, or even or faster, around a megahertz. Actually, yeah, it's around 1 or half a megahertz. So yeah, so around 1 or 2 microseconds. But what happens is then when RF comes in, it's got extra energy coming in, and so it can oscillate quicker. And so you get this kind of wacky sawtooth wave that's either running at around a megahertz, or else it like doubles up to like 2 or 3 or 4 megahertz when something's coming in. And then you put a low pass filter and you integrate it, and then you ram it through an op amp or something to square it up. And but basically that that active circuit, it's one transistor. To me, that's just so cool, right?
It's pretty
awesome.
Minimalist. Yeah. I love it.
And they had all sorts of problems, right? They drifted like crazy and all that. But so anyhow, that was the thing that the guy said, fix this. Right? It's like, oh, okay. So first it was like, well, what the hell does it do? How does this thing actually work? And so that was fun.
So what'd you do great. after this car alarm stuff?
Well, so what happened was I was there for 2 years, and at the ripe old age of about 25, I was the go-to guy. I'm like, oh, this is wrong. Right?
Like, yeah, if you look around a room and you're the smartest guy there, you're in the wrong room.
Exactly.
Right? That kind of thing.
Age, holy crap, that's just wrong, right? So I said, I'm the go-to guy. I don't know anything, right? So I managed. So I'm like, okay, I got to find some place where, first of all, I learned, because it was a small company, I learned that if you want to be an RF engineer, you got to have equipment, right? And
it helps.
Lots of it. And it's all really expensive, right? So,
right.
That's why our esteemed third wheel co-host Jeff buggered off to Valve, because he wanted the test gear to work on RF. He can't afford it at home. It's just you know.
That's a tough road to hoe. Yeah, exactly. That's I mean, I've got my own smattering of RF stuff at home, but it's all pretty vintage, and certainly nothing I'd want to try to work on like Bluetooth or Wi-Fi or something like that with. It's,
right.
And so I looked around and said, okay, where are there like a bunch of RF engineer kind of gray hair that I can really learn from, right? And so Ford Electronics was just down the road, because that's one of the advantages of this whole automotive thing going on here in Michigan.
Ford Electronics, they were a separate company, were
Ford
they?
Electronics,
like a subsidiary.
Yeah, exactly. Yeah, it was a separate company.
Right.
Yep. So so I said, okay, hey, that's pretty cool. I can go be a punk and learn from the guys there, and success. Really after a couple years, really got some just awesome on the job training from some super knowledgeable guys, and AM/FM tuner stuff, and more of the UHF remote entry stuff, and then even the low frequency, the immobilizer, that that 125 kilohertz RFID stuff, right?
Yep.
So
which are actually, if people don't know, they actually embed these RFID tags inside the key. So that's how you can't, you can't. That's part of this, car alarm security thing. You can't start the car without the proper key that has the RFID tag. Is that correct?
Right, exactly. Yeah,
Tom?
your key's got. Yep. I mean, there's only I think it's 3,000 combinations. Really? There are always these stories of my wife and I, we both got a Ford, and we use the same key. you go, oh, that's no way, and it's like, no, definitely possible. It's there.
Yeah. And, well, it's if the key has to be the same too, right? I mean, like the key would be the same, and the RFID would have to be the same.
Oh yeah, now I'm sorry. What I meant was, back in the olden days before the.
Oh, back in the day, I got
you. That pellet or that tag, that's a 32 or no, it's longer than that, 64, and actually that's evolved, right? That's gotten better over time.
I'm sure it's gotten bigger and bigger with time. Yeah.
Oh yeah. Okay. Right. Okay. I thought you meant
no, but just the mechanical key. Sorry. Like I said, there's only about 3,000 combinations of the key.
I got you.
So,
yeah,
and
that's pretty crazy.
So,
I think that's a really smart idea what you did there. I mean, we were talking about careers last week, but I mean, going where, especially if you don't necessarily have any like, I need to live here. If you need to move to Florida or something like that or whatever. If you do want to chase talent, that's a really smart idea to go where there's a lot of people to teach you and a lot of room for mentorship. I think that was a really smart move on your part.
Well, and I also think it was. I think it was kind of fortunate too in terms of kind of the way things work at the time, right? I think now I don't know how well that'll. I mean, I still think it's a good idea. I still think it's a good strategy. But just everyone is so lean now, right? I mean, this was kind of this. This wasn't. Things weren't quite. We weren't super fat and happy then, but it certainly was pretty cozy. Let's put it that way. So at Ford, so
there was time to work on special projects, that kind of cozy.
That kind of cozy, right? Yeah. Or just kind of. It was awesome setup. They had like about 20 of these little individual RF shielded rooms, right? And each one had a full bench set up with a spec GaN and RF gens, and a few of them had network analyze. It was just. It was just. I just needed a towel all the time. I was drooling so much. It was just great, yeah. And so you kind of go, let's knock on room number 7 here, see what's going on. Oh, hey, so-and-so's working on a new IF amplifier or something. Okay, cool. So it was awesome. It was cool.
Oh, that's
really cool.
And you end up taking that sort of those resources for granted too. I found, when you work at big companies like that, who spend millions and tens of millions on setups and labs and things, you really take that for granted. When you go somewhere else, and you've got, a multimeter and an oscilloscope and a pair of wire cutters on your desk.
I was going to say, I miss my test gear from Keithley. I definitely am lacking these days. But.
Yeah, well, for me, I didn't take it for granted because I came from the pauper place, right? I mean, honestly, it was the car alarm company once a year. For a month, they would rent a network analyzer, right? I mean, that's right. So you sort of queued up all your antenna matching and, okay. And then that thing showed up, and then we all just used that thing around. There was about 3 of us, and we all used it just around the clock, and you just booked weekends, and oh my God.
Wow.
It was, and then it's like, well, see you next year. I hope this works.
Hope this works.
Yeah, it was a lot of that. So coming from that into... Wow, I got my own shielded room with, $2 million worth of stuff sitting in front of me. Like, oh, yeah, okay.
Yeah.
But you're right. It's easy to take for granted if you're not.
So you were working on RF electronics. Was that your main forte at Ford?
Yeah. Yeah, and so that was, again, sort of the remote keyless entry stuff, so the car opening stuff. And then that kind of... eventually kind of broadened out, right? So, I mean, I've always kind of had RF as a competency, but, I kind of had that, I picked up that microcontroller background at the other place, and, I've always liked analog electronics in general, so, actually, what Jeff, last week, he mentioned something like, was it the T model, kind of?
Yeah, being a T,
Yep, right.
And I definitely feel like a T, where my pillar there is RF, and then kind of a smattering of other stuff to varying degrees, enough to be dangerous in some areas and enough.
Better watch out, man. They're going to try and get you out to Seattle if you keep talking like that. So just be careful what you say on the show. That's all I'm saying.
I don't know. It sounded like that was one hell of an interview vetting process.
Yeah.
But
and I had a question about RF and just in cars in general. I mean, how long have those remote keyless entries been around even? I mean, have those been... I know my buddy's like old Buick had one, and that was probably like a 1990s kind of car. But like, what year did they start really introducing those?
So they were first through the aftermarket, right? So like these little goofy car alarm companies and stuff like that. Yep, and there you're kind of into like the early to mid 80s, I guess.
Okay. Is that how most auto electronics starts? It starts as third-party stuff because they've got less regulatory, and faster development cycles and all that sort of stuff. So you can buy all these car accessories and the automakers go, oh, people like that stuff, do they?
It's a feature.
We'll look at incorporating that. And it takes 10 years. And to me, it seems like it takes like 10 years for something you can buy as an aftermarket thing to when it filters into an actual production car or a production car that your average Joe buys anyway, as opposed to like a Mercedes SC class or something like that.
Right. Not so much for your average Joe, right? Yeah.
Yeah. Because I remember it took so long for like a USB like a CD player to play MP3s, right, in a car. That was like, it took forever. Like, how hard can that, you could just buy an off-the-shelf one and stick it in. Like, I don't know.
Yeah, no, you're absolutely right, Dave, that, and for the reasons you said, right, that really, look, in terms of, from the automaker side, or, I'll probably say it sooner or later. So OEM, that's always the key word for automaker. So I'm sure I'll lapse into that. Just there's way too many TLAs, 3-letter acronyms in the auto industry, right? So so anyhow, so the automakers, they're not going to want to make like 1,000 or 2,000, right? I mean, it's always, we're going to commit to this as sort of an option level in a particular vehicle platform, and it's going to be at least like 100,000 pieces, right? And then, and they're just so used to really long design cycles and all the qualification and all this other stuff that hopefully we'll get into. And so you're absolutely right that the stuff starts off in the aftermarket, and I mean, and it's not only radios that don't suck, but it's also things like LED lighting inside cars, all this ambient lighting and kind of neat mood lighting and stuff. I mean, that's been in cars for ages now from the aftermarket. And, and so for the past few years, you've been seeing it in actual production models too. But it's you said 10 years. I went, oh, no way. And it's like, well, no, you're probably about right, actually.
That's what it seems.
It's almost like the app model too, like how like Google and Apple and all them, they see apps and then they're like, no, we'll roll that into the next release, for like phones and stuff like that. It seems like it's smart. It's a smart idea. You see what works first and then you push it in. If people aren't screaming about it, why not,
Because the problem with the automotive industry, which is why we got Tom on the show, we wanted him to talk about this sort of stuff, is the development cycle time and the regulatory approval process and all that sort of stuff. It's, it's very lengthy and very difficult just to put into a car what you think might be something simple like LED mood lighting, right? You can't just stick it in there. It's, it's got to go through regulatory approval, probably not as much as like an anti-lock braking system or something like that. But still, it's, I'm sure Tom's going to tell us about it, right, Tom?
Sure, absolutely. Yeah. I mean, that design cycle though, you're banging on though. I mean, it's, for a typical, and so I guess and here's where I have to really make clear. So my experience, I've never made a car before.
Right.
Wait a second. Why is he on the show, dude? He said he makes cars.
Exactly.
I thought you were a T-model engineer. Come on.
I'm not quite that old
right.
yet. And no, so and so in the auto speak, it's you make modules, right? And so there's just modules everywhere, right? And back in in the 80s and 90s, there weren't really any modules. It was like your radio, and then
right.
That was probably the most complicated thing in your car, right? And it's just and to me, really. So I left Ford in '95 and entered the automotive supply chain, right? So I went to work for TRW Automotive for a number of years, and then went to work for a company called Leader for a few years after that. So again, they're kind of competitors of each other. Pretty typical in the industry too. They're all in the same geographic area. So it's we're kind of like migrant workers,
right?
Bouncing
between them, right? Across the street, get a little bit more money.
Beans. Yep. Yeah, when the beans are picked, they'll go across the street. Yeah, exactly. Yeah. But you're right. I mean, so typically, so when the automaker decides they're actually going to do something like your LED mood lighting or a radio with a USB port or whatever, you're really talking about, I guess, assuming that everyone's really decided, all the functional of, right. what it's going to do and how it's going to do it, that actual design cycle, it's about 30 months.
Whoa.
So yeah.
Wow.
And really, in about a third of that time is just pure testing time.
And then, that's amazing, because in the general electronics industry, most people don't even last at a company for 30 months. They'll get bored because they've already worked on 4 projects and they're buggered off to another company.
And then, does that happen? I mean, does that same kind of thing happen in the auto industry, or is there less turnover there?
I mean, there's certainly turnover, but I guess maybe it just proceeds at a slower pace then, right. I mean, usually, I mean, it's pretty, I don't know. I mean, so you can tell at this point, I've quit more than a couple jobs. Right? And, it's always a crappy feeling to quit before something's, finished, right? Or at least, sort of finished-ish, right? And
right.
So, I mean, there's turnover, but it's, it tends to, I mean, so it kind of tends to align with when the project launches or so. And
I suppose there's such a design center there, right? There's such a cluster in Detroit, in the Detroit area, or in the metropolitan area and stuff, that it's like there's not as much incentive to move across the country, right? Or maybe outside of Detroit in the area, you'd have to go so far to move that it wouldn't make sense, right? I mean, there's only so many places around there.
Well, and I mean, I'd say it's just more of kind of a convenience factor, right? I mean, I guess I turned the other way around and say, like, look, I've already got a house and a family and all that other stuff, and there's 7 more companies I could work for, and without even having to think about or think too hard about other names, and sure, go see what's going on over there, right? So
yeah, I gotcha. Yeah. Okay,
and that's starting to happen again. Actually, that's started to really pick up in the last in the last year or so. And
churn between companies.
Oh, kinda. Yeah, the churn. And it's funny because now that I'm, like I said, so about 6 years ago, I turned to the dark side and went to work for a chip maker. So I've kind of had this trajectory of heading towards the basement of the supply chain, right? I mean, it's and so
next up, you're going to be the broker or the salesperson. Is that?
Oh God! No, I'll probably shoot myself before that.
I don't know. You probably won't notice the slide to the dark, to the complete end of the dark side.
All you'll see is more zeros on your paycheck, Tom. I mean, that's all I'm saying.
I'll just wake up and go, "Oh my God." What am I doing?
Why am I selling everything? I sold my kids.
Exactly. I'm a bad man. Yeah. So, and so it's really amusing in this position because now it's so basically these companies where I used to work, now they're my customers, right? Which is cool. I mean,
right.
Actually, it's a lot of fun because all the people I still work with, I get to see them all the time. It's great, and then I can take them out to lunch, and then my lunch is paid for too, and everything's good, right?
Nice.
Yeah, exactly. So, but it's funny then because now I've got the visibility of like all the people plotting of where they're going to work next, and it's kind of funny because like, oh. What do you think? What's going on over at so and so place?
Oh,
yeah.
Well,
right, yeah.
I'm kind of thinking like, in probably about another few weeks, there's going to be an opening because there's a guy over there that's looking. So,
yeah, he's taking your job.
Exactly right. Yeah.
So you're right. Honestly, the darkest side I could turn to is I could become a recruiter. Right? I mean, that would be.
Don't do it.
Exactly. And then
Oh boy. So we're talking a 30-month design cycle. How was that broken down? How much is actual design time? How much is regulatory? How much is testing? How much is just general red tape? Or
Sure. So, and I'm going to kind of, obviously this is sort of a hypothetical, right? I mean, in terms of generally speaking, right? But in general, of the 30 months, there's about a third, so about 10 months of that in two 4 or 5 month chunks are really just crazy serious testing, right? And so like you're kind of like your highly accelerated life testing, your stress testing, shaker tables, thermal chambers, all that good stuff. Well,
because I was going to say
fun.
the three things you care about in automotive and really have to rigorously test for would be vibration, shock and vibration, temperature, and RFI immunity, right? They're the three key things.
And I'd probably add a fourth.
That can go wrong?
I'd probably add a fourth and say that really the whole some people kind of lump it into RFI or immunity, but also, it's a 12-volt battery, but boy, that's just one messy power supply, right?
Right. If your alternator fails and all that sort of,
exactly,
you can get huge spikes, can't you, on your automotive systems?
Oh yeah. Yeah, there's
huge amounts of energy too, like not just voltage, as in a small amount of current. We're talking huge energy. Wham.
Yeah, it's joules. Yeah, I mean...
Joule, we're talking joules. Yeah, it's not, nanojoules.
No, joules. No prefix. Right? So,
right.
And that's the really
surge,
cool one.
Of course,
that's the load dump, right? So it's and so it's anywhere from about a 40 to there's a whole bunch of standard pulses. ISO kind of standardizes the one, but I'd say kind of a typical load dump pulse is about 90 volts. It's maybe about 300 milliseconds long, and it's got and the source impedance is in the single digit ohms, and so you work all that out, and it's around like 300 to 400 joules of energy. Yep. Wow. And it used to be that every module had to just survive this test, right? And it just and so you've got these big crazy these varistors and huge transorbs and all this other stuff, and they kind of, I think the automakers got sick of paying for one of those per module, so they've kind of toned things down, and they've designated that either they've taken they've kind of divvied up the modules and said, okay, you 4 guys over there, you're going to have this junk in it, and then all the rest of you modules, you don't need to have this, and so then you get to test it to a lesser spec, and so, but I mean, there's all these dips and drops, you call it, so that it's really just interrupting the supply and all that stuff. Yeah, so I'd add a 4.
So all your vital modules, like your anti-lock braking systems and things, your really essential ones that stop people, from dying, they would be the really critical ones you would have to protect. Whereas you wouldn't care about surge overload on your mood LED lighting controller or something, perhaps.
Well, it's not so much that it can't blow up. I mean, I don't care if it's the mood lighting controller or not. I mean, that's not acceptable.
No smoke. Right?
No smoke allowed. No smoke. Right.
Right.
And so really, there's there's varying levels of so it's the acceptance criteria, right? It's and this the same goes for like, for example,
that's word of the day. Acceptance criteria.
Well, that's not your fault, is it?
And so, and same goes for like the immunity testing for RF2, right? It's, look, everybody's got to go. All the modules have to, they all have to go through immunity testing.
Yep.
But for example, your LED mood lighting, it's maybe look, at 30 volts per meter field, you got to work.
Yep.
At 60 volts per meter field, fine, I don't care. Don't lock up. Don't make smoke. As soon as I take the field away, you better work again. But that's okay. That sort of loss of function is allowed. And then, but like, for example, like a powertrain controller or a transmission controller or an airbag module or ABS, you're up into like the 1 to 200 volts per meter.
Yep.
And, then it's sort of, well, you have, degraded functionality, but for example, you can't kill anybody. Right? Yeah.
Yeah, you have safe shutdown, that kind of thing, right?
Yeah. Have you ever worked on the airbag stuff?
A little bit.
Or is there some third-party company? Does every manufacturer do their own, or is there some third-party company that really specializes in, say, airbag controllers, and they're the world's best at it and that sort of thing?
Well, there's the supply chain, right? You've got the automakers or the OEMs or the customers, right? And then you've got this so-called tier 1 level. These are the guys that they get the specs from the OEM. and then they say, okay, we'll develop this product and we'll sell you this module or we'll sell you this subsystem. And yeah, there are some tier one supply, and these are big names. These are like your TRWs and your Siemens, and they're not called Siemens anymore, but okay, fine. So these are your big names, and so they all have kind of their own, I'd say, core competencies, their own specialties. So they don't all make airbag modules, but actually a number of them do, right? And that's definitely really serious stuff.
I was going to say that.
Yeah, and as an engineer, that's kind of it's really creepy. Actually, I mean, I thought it was, right. It's sort of like, ooh, man, if this doesn't work, like someone could die.
Yeah, that's right.
Yeah, your failure rate of 0.001%. That's still.
I know it's still.
That's still dead bodies, right?
I know.
Yeah, exactly.
Yeah, that sucks.
Yeah, and as an engineer, you're going to get called into depositions and stuff like that. It's like, yeah, good times.
No.
Right.
Yeah.
Have you ever been involved in stuff like that?
Yeah.
Yeah. Okay.
Yeah. And
as an expert witness, or are you trying to defend yourself as that?
Well, it's sort of so for the company I was working at that time, who made airbag modules, there was here's another potential wank word warning. There was an inadvertent deployment.
Right.
Yeah, so
you punched someone in the face with an airbag, huh?
Yeah,
someone died. There was an inadvertent deployment.
Yeah, and so it was bad, right?
Yeah.
But fortunately the line of questioning was just sort of did you follow the procedures? Like, yes, of course I did.
And as long as you follow the procedures, nobody's at fault. Even if the procedures are wrong, it's great.
Yeah,
I love it. That's how big companies work, right?
You settle, right? Exactly. I mean, I don't know where that case went. I'm sure it settled, right? Yeah.
That's a mess.
Yeah, it is a mess. So yeah, that's kind of the darker side, right? Is that the safety stuff, but the good news is the safety stuff, it's working, right? The mortality rate in the U.S. at least, the mortality rate, it's this past year, it's about half of what it was in like the 1960s, 1970s.
Yeah.
And you consider there's a hell of a lot more cars on the road.
And there's a lot, I was going to say, a lot more, and they're going faster, and they're, so,
right.
Yeah.
And people aren't getting better at driving at all. I mean, they're getting worse, if anything. Yeah, so.
Yeah.
So what sort of, with regards to temperature, what sort of temperature ranges do you test these electronics over? And is it market dependent? Because like here in Australia, I can remember I got my car, and it's a European car, right? It's a German car, and it came with a freaking battery warmer, right? This, this little cover that goes over the battery to keep it warm in Australia.
Yeah, we probably wouldn't need that here in Detroit or Cleveland either, right?
Unbelievable.
Yeah, that's the whole product marketing side. Sounds like a failure there, right? Like, we could probably dial back on the take level for the battery warmers and Australia. So normally so again, it kind of depends on where the electronics are in the car. So if you're just in the passenger compartment somewhere, typically you're -40 to +85 C.
Yep.
And then
just only from -40 to +85.
Oh, that's the easy one.
Yeah,
right.
Yeah, that's the mid tier.
That's sort of the you can't cut that.
The cheapest parts out there, as far as I know, are 0 to 70 parts. Maybe there's even more strange
there's three levels, right, of chips. There is the consumer temperature grade, there's the automotive temperature grade, and there's the military temperature grade.
You have industrial in there too, though.
I think industrial and auto are usually the same.
Yeah.
They're usually the same, and so that's normally your -40 to +85.
Yeah.
And then honestly, inside the passenger cabin, but like if you're on the roof, if you're on the inside of the roof, like an overhead console kind of thing.
Right, yeah.
Because there's heat rising, so then
you're right. And you're right under the metal roof plate, right? Yeah.
Right. And so then you're 105 C.
Yeah. That's what I think of it as automotive. I would think 85 is usually industrial and 105 is automotive, because I never buy 105 because you have to pay more.
Exactly. Ooh, bad parts.
Yeah.
Over-engineered.
So I doubt you'd be using any electrolytic caps in there, right?
Oh, no,
there's dry out pretty quick.
There's 105C electrolytic caps.
Really?
Sure. Yeah.
Even in those roof modules?
All it takes is money. Sure.
Right, okay. And buy them from a reputable
So you like insulate the circuits with money? Is that how it works, or what?
Right, wrap dollar bills around your electrolytic caps.
No, there's a lot of actually there's a lot of 105C rated caps now that are available, electrolytic caps.
Crazy.
And then if you're in the engine compartment, then you're the -40 to +125. So not quite mil, because mil is like -55 to 125.
Yeah.
Okay.
But I mean, -55 is nuts. That's -40 is kind of normal. So.
Where the hell do you get those sort of negative temperatures? Siberia or
Bemidji, Minnesota. Ask me how I know that.
Okay.
Ooh,
how do you know that?
That's actually, and there's other places too. But that's a Ford Electronics, or Ford has a cold temperature test range there. And in the wintertime, the average temps, I think they're about -25. So they're kind of like that -30 to maybe around 0. And,
wow.
Yeah, I got
so are you guys working in all? I mean, are you work all metric? I guess that was another question of mine. Or is it just at temps? It's always convenient to do Celsius.
It's pretty much all metric.
Nice. Even like engine compartment, like measuring like engine block stuff.
Oh, definitely. Yeah.
Yeah. Oh, yeah. That's great.
I mean, but there's a lot of holdovers, right? I mean, like, I'm sorry. If someone starts telling me about like how powerful their cool new car is in kilowatts, I just give them a blank look. Like, whatever.
What's that in horsepower?
Exactly. Yeah, and even the Germans, right? I mean, so I work for a German company now, right? So even the Germans, they don't talk about kilowatts. They talk about they have right? It's like Purgesturgen, or it's like a German horse. I'm sure it's better. Right?
Yeah. So it's like real snooty and thinks it's better than you.
It's I'm sure it's.
Sorry, German listeners. I'm sorry. I work with Germans too. I love them.
So yeah, it's about a horsepower. I think it's actually a little bit. I think a PS is a little bit more. So and they don't say kilowatts, or at least I've never heard anybody say kilowatt. So there's some holdovers, right? Kilowatts, and
those are almost like colloquial, though. It's not like.
Right.
That's not like a measurement so much as just it's like a judgment, It's like I don't know. It's an anecdote.
It's marketing.
Yeah, it's marketing. Exactly.
Yeah. Well, and quite honestly, you're exactly right that when it comes right down to it, there's only a handful of people that, how many kilowatts or horsepower the engine's making, it really matters, right? I mean, to the rest of us, it's just sort of a yardstick, right? For how do we...
Or is it a meter stick?
Or a meter.
Right.
Thank you.
I was going to say that earlier. That's why I called that out.
You were quick on that. Yeah. So absolutely that. Yeah, it's mostly metric. But that being said, there are an awful lot of really strange metric numbers, right? That are obviously inch equivalents, right?
Yep.
So, yeah. So I would say that measurements are conducted in metric, but the parts that are being purchased are the same old parts as before.
I get you.
Yeah.
Okay.
Yeah.
So we talked about power on here, or when you and I had talked before the show, we had mentioned power, and you said that that's a pretty significant part of a lot of car design is just dealing with. We talked about the surge dump. What was it called? The
load dump.
Load dump, right? Yeah,
that's supposed to simulate what happens if you're driving down the road and like your battery cable falls off the battery, right? And
wow.
So the alternator's got this big, huge chunk of energy it wants to give to someone, and it can't give it to the battery anymore, so it has to go everywhere else. So,
oh my god.
Yeah.
Wow. So are there are there a lot of other big power concerns within the engine compartment or even the cabin? I mean.
Well, I mean, there's certainly, because of the wide temp range, for example, so even with the 85C upper limit, you've really got to pay attention to, so basically what happens then is really every design engineer has a very good working knowledge about, R theta JA and, how that all matters, so, to really know how to do that thermal analysis, because, automotive electronics, it's for the most part, it's not, especially in the body stuff, it's not rocket science, right? You've got some controller, you got a bunch of inputs, you got a bunch of outputs, and usually those outputs are, they're actuators, so there's a lot of motors or things like this, and or lamps or loads like that, and so they need a fair amount of power to drive them, and so you've really got to pay attention to properly derating and making sure you've got some proper PCB designed for heat sinking and all that sort of good stuff. Okay. So, yeah. So really, I would say that's in my mind at least, that's a huge difference between like your typical consumer electronic stuff, right? I can't. Right. I've lost track of how many. God, for me, it's been these stupid USB external drives. Hard drive in a box with a little USB bridge. I think like 4. If I leave them plugged in, kind of like as an external. I think I've burned up like 4 of them, right?
Yeah.
I'm not like putting them in a shoebox full of socks or something. I mean, they're just sitting on top of the computer, right? But,
it's vibrating a little bit,
and in every
right?
case, the hard drive was fine.
Oh,
it was the stupid little USB bridge board, and I'm sure it just died a heat death. I mean,
right? Yeah. Well, because they're not. They don't care. They don't have the stringent.
Yeah, you pegged it, Dave.
That's the bottom line, right? They don't care, right? Because they don't. Okay, I'm not going to say anymore. Nothing more needs to be said. They don't care.
I mean, Tom, how much are you paying for these boxes? I'm guessing not much, right?
Right. But I mean, I honestly, sometimes I'd be willing to pay double if I could get one that didn't suck.
Yeah, no, that's true.
Yeah.
And that price is kind of baked. Agree. I mean, is that baked into car electronics, or is it just because? I mean, I think about like I drive a Civic, simple car, but still like a good chunk of money. But like all the junk that's in there, like the pricing on that and just the economies of scale are just huge. And so like, is quality always in there? I mean, is there any kind of derating from top to bottom if I buy like a Mercedes versus a Civic? I mean, like, what is it? I mean,
it's funny that I really it's not so much that you're buying the Mercedes, so the quality is 10 times better, therefore reflected in the price, right? I mean, it's. I mean, I think we saw the U.S. car companies learn this, right? That hey, turns out if you build a car that's crappy, even if it's cheaper, you get a bad, you really get a bad name, right? So the 80s were just and so that's a really serious thing. And so the quality really is baked in everywhere. And so really the difference is, I mean, I think you're seeing is that it's more in just how many bells and whistles are in the cars, right? I mean, fine, or in the really high end car, I can get the bigger, more powerful engine that I can't get in the smaller car, or it's just bigger, for example. So
then the rest is just brand name and you're paying for luxury, quote unquote, and all that other crap too.
Yeah, you're paying for luxury, or it's like a little bit of feature functionality kind of stuff, but I'd say the differences are probably a lot more in like the whole man-machine interface area than they are in just carrying out the functions of being an automobile, right? Yeah,
I get you.
Yeah. Because because the car's cheap, it can't get crappy gas mileage, it can't have bad power or whatever. I mean, that's not going to be accepted, right?
Well, there's a certain minimum thing that people expect these days in a car. They expect it to last, be reliable for. I mean, cars are getting. I don't know about in the US, but here they've got like a 5-year, 100,000K warranty, right? Which is 50,000 miles or something, 60,000 mile warranty.
Yeah. Yep.
Right, which is pretty substantial, and so they're obviously building them, and that wasn't the case 15, 20 years ago, right? You were lucky to get freaking warranty at all with a car, I think.
Right, 15 months. Right.
Yeah, whereas now it's it's that's one of the incentives to buying a new car is that the fact it's going to be trouble free and it won't cost you anything apart from service for 5 years or something. So
Tom, when you go be a recruiter, Dave's going to go sell cars. You can hear it in his voice already.
We'll get him. We'll get him a plaid sport jacket, and we'll set him up. It'll be awesome.
How can I get you into this car today?
Patches,
I'm thinking of a number.
Oh my goodness.
Yep.
You're right there. That's sort of the lowest of the low right there.
Oh, good. We're not the only ones who think that. Yeah.
No.
Everybody in the car industry thinks that too.
Yeah. No, and well, it's funny because even that's changed, right? I mean, even the used cars, right? It's now they're not used; they're pre-owned, and
and you can buy a used car with a 3-year warranty here.
Exactly. Yeah, they're certified by the manufacturer now.
They're certified by the manufacturer.
Yeah.
Yep.
Yeah. So
do they rip out electronics for that too? I mean, do they change out electronics when they do that? I don't know if you know that stuff because obviously that's at a warranty company or whatever. But like, what is the longevity expected from electronics? I guess that's what it ultimately comes down to. Is it 10 years, 20 years?
10 years, and so it's always the expectation is 10 years, 100,000 miles.
Wow.
Yeah.
Right.
Yeah, and but
so you guys asked for that from your vendors then? I mean, you're a vendor now, but
yeah.
You were asking that from chip companies and stuff?
Yeah, exactly. So and most of these things they really are they really are powered for 10 years, right? I mean, it's not like it's even though the key's off, there's a lot of stuff in your car that's
still on. Yeah, that's right.
It used to be the ignition switch in your car was this 40 amp switch, right?
Yeah,
that's right. That sucker off and it just went cold, and that ain't the case anymore. There's all sorts of stuff on. And everything's all networked together. There's all these buses and things like that.
Oh, CAN bus,
well,
right?
It can, right?
Yeah, CAN.
Why? What is it? Only CAN, or is that's the impression I get? Is that CAN bus is the standard in automotive? End of story.
At this point, it's CAN. Prior to CAN taking over here in the U.S., that was probably about 2005 or so. There was a there was a. So there've been automotive buses since like the 80s, right? I mean,
yeah.
With varying amounts of success and things like that. But the CAN kind of won out in I'd say mid 2000s. But before that, there was a one that was standardized under the SAE, the Society of Automotive Engineers, and it was really a mess because basically it wasn't a standard. It was kind of this umbrella thing that sat over the Ford way and the GM way and the Chrysler way, and they're all totally different, but they all had the same.
Yep.
It was.
So why did CAN bus win out? Is it because it was forced on the manufacturers by some standards?
What happened?
Or something or
no? That's a good question. So CAN. I think CAN. So yeah, I don't know the answer. I'm going to speculate recklessly. I think it won out because it had a tremendous amount of traction behind it in terms of the components that you could buy from the chip makers that supported CAN.
Yep.
Because the various flavors, the GM and the Ford and the Chrysler flavors, those were standalone kind of bus interface chips, not just the physical layer, but also like the Mac, right? They were standalone chips, and that's expensive, and and I can't.
And they license it too, right?
Yeah,
I mean, that's only
and Bosch is the one that came up with CAN. I mean, God, in the 80s as well, and it's still around today. And honestly, it works pretty well. So I'd say it's good enough. It's a little slow by modern standards. It pretty much tops out. It tops out at about a megabit. And so there's newer, faster ones. There's FlexRay, and there's some optical ones that are called MOST and things like that.
Right, but people always end up comparing these bus standards to like Ethernet, but isn't CAN's like single, or it's two device, right?
No,
CAN's more like RS-485, I believe.
CAN's a multi-drop. It's
okay.
But basically what's interesting about CAN is that built into the physical layer is arbitration.
Oh, okay. So there's no collisions. Yeah. That's what I was getting at. Is that Ethernet has tons of collisions that can slow everything way down.
Right, and that's what makes CAN really attractive, right? Is that the chronometrics, right? I can really count on when am I going to get. There's another word.
There's a word, chronometrics.
Yeah, that's got to win.
When
that might get into the title, I got to say.
Oh yes, that might be the title, chronometrics. I agree.
So, and I'm by no means a CAN bus expert, but that's really a key point of it, though, is that the arbitration is built right into the protocol. It's built into the physical layer. It's got more fail-safe and safety stuff than it just blows your mind. So, I mean, as far as it's every CAN node has to be able to shut itself off if it thinks it's babbling on the bus, and I mean, it's incredible. I mean,
is there only one CAN bus in the car, or are there dozens? Because I know that there's like hundreds of modules in modern cars, isn't there? Or it can be upwards in a really high-spec, complicated car, right?
I'd say up to 100.
That's what I've been hearing, right?
Yeah, absolutely.
Yeah.
So typically what happens is you've got a high-speed CAN, that's your 1 megabit, and that's your powertrain bus. And so on that, you've got your transmission controller, you've got your engine controller, they live on that, and then like they'll usually connect up to like your instrument cluster. and that acts as a gateway, right?
Right, because you wouldn't want your LED mood lighting controller taking down your powertrain, right? That's the idea.
Right. Try explaining that one to the CEO.
Yeah.
For, right?
Right.
Yeah, sorry.
Who tested this?
Yeah.
Go back to testing for another 10 months.
Right. Ooh.
And Corey.
Yeah.
Well, how could you test and ensure the interaction of 100 different modules on the one bus? It'd be next to impossible, right? So you would have to, just as a, just to ensure that you're going to meet your reliability targets for your critical stuff, like your powertrain, you'd have to isolate them.
Right, but honestly, it's not broken into that many buses. I mean, so typically you've got
Right.
this high speed bus for the powertrain, and you've usually got one bus that's for the body stuff. And
that's
that maybe
what I would
runs
have
at like
expected,
50
like 2 or 3 top.
Yeah, 50 or 100 kbit, something like that, and some run really low.
And there might be 50 modules hanging off that car bus,
Yeah. And honestly, what's happened is that, I mean, so the CAN hardware, it costs. I mean, it's not super expensive, but you're gonna spend 50 cents or so to get a CAN transceiver, right, in high volume.
Yep.
So, and so what's happened then is there's this LIN bus, right? So you probably heard of that before. Yeah. Okay. So that was created to be a sub bus. Right.
Right.
And that's super cheap. That's a UART based protocol.
Yep.
And you can do that. I mean, it's just, it's a big open collector or open drain, So it's, Yep. And so, so what happens then is you really remove the number of clients that are on the CAN bus, so that number is really not super high. And then you kind of put your sub modules on these independent sub buses.
Right.
And then those don't share, and then you have many of these LIN buses, for example. So,
would the airbags and things like that be on the CAN bus?
Absolutely, yeah.
Because they would have to report back, right? Because at the end, you've got all these, warning lights come up when your airbags have failed or something like that if it doesn't get the report back saying it's,
Right, but the other thing I guess is key to point out too is that, like, for example, in the case of like an airbag, like, it's not that the airbag, so the squib, that's the propeller, that's the charge, that's not sitting on the CAN bus. And
that'd be its own. That works autonomously, even if the CAN bus interface fails. Right, the airbag would still work.
Exactly. Right. Yeah. Right. And so for example, all the sensors that feed into the airbag module for the crash decision, and then all the firing loops. Yeah, these are all dedicated copper. Yeah.
Yeah.
Right. So is it all? So that means it's all like down and embedded. Everything's embedded in cars basically, and then they're just throwing back messages. Is that kind of the idea?
Yeah. So what's on the CAN bus? It's information that gets published, and that's really where the automotive, where the OEM does the systems engineering, right? It's an incredible task, right, of really deciding, what's the information that's on the CAN bus, in order that, so you've got the publishers and you've got the clients that want the information and working it all out as to how often it's published, and so stuff like what's the engine RPMs, what's the battery voltage, that stuff's floating out there all the time, and then less frequently are things like are the doors locked or not, or so so
there's now talk about having, like, there's the ODB bus. I don't know what that stands for offhand, but that's
you know me.
Onboard diagnostics, right?
Right.
And they're talking about, I think some cars have now got that accessible on the instrument panel. Like, you can actually plug like stuff into it. I've heard that this is going to be the new thing. Like, and it's going to be open, like, so that you can design like open products to plug into these buses. Have you heard anything about that, or is that only a selling?
I think it's already here.
Oh,
no.
right.
I think, it's that OBD, that onboard diagnostics, and that was sort of started by California a long time ago, right? When that was part of their clean air.
Oh, right.
Actions that they've been so famous for over the years, and so one of them was, hey, we got to have or what kind of came out of that somehow was a standardized engine. So it was started off just being your engine diagnostic connector, and but it's a standard connector. It's got a standard pinout, and it's always pretty accessible. I mean, it used to be just kind of underneath the, underneath the instrument panel kind of thing, on above your feet, and it moves around, to put it in somewhere that's sort of accessible but not obtrusive. And then, but all that is it's just where the CAN bus goes to, and it's nothing new. It's just a connector.
Yeah, like it's a drop basically, or a access point.
Yeah, exactly.
Right.
It's a drop. Yeah,
okay.
Yeah. And there's a set of standard messages then that appear on that, and so that's why you can go to like your local auto supply store, right, and you can buy for like $20 or $30, you can buy a little thing that'll read out the diagnostic codes, and yeah, so it's all standardized and spec locked down. So
nice.
I think that's what you're talking about, Dave. Or is it something different?
Well, yeah, but I've heard.
Dave, are you talking about that thing with Ford and Bug Labs, how they were collaborating together?
That could be it, yes.
I think you might be talking
where
about
it came from. Was that, now they're actually...
That was like the infotainment system, though. That was I don't think there was any useful information on there.
Okay, got it.
Yeah. We've mentioned that on here before.
Right.
But infotainment, horrible term.
I know, in the car,
that is so not automotive electronics. It's
right, yeah, I know. It's home entertainment, right? It's home hi-fi.
And watching, and it's actually hilarious watching the infotainment crew interact with like your hardcore,
Oh yeah,
like,
right.
It's like, wow.
So you want to put a screen where underneath the hood? Why? I don't get
it. In terms of so again, for automotive, obsolescence is a huge thing, right?
Yeah.
That you've got to be, so typically what happens, you go through 30-month design cycle, you've gone through this horrible bouts of testing. And the thing's done. It's approved, right? It's ready to go into volume production, and typically that'll run, and it gets put on, one or more vehicle, platforms, right? So several different, kind models of vehicle types, models, right? And that'll typically run for 3, 4, 5 years, something like that. And if turns out you don't need it, if it's working fine, everybody's happy, fine, you let it ride, let it go again, right? Or or usually it's make it cheaper,
Right.
Well, I can imagine it wouldn't be uncommon for the same module to be used for 10 years in different models as they evolve. Because why redesign it if the functionality is going to stay the same for some, anti-lock braking system, right? You just keep it the same across all your models.
You would think.
Oh, right.
But,
okay.
No, it's always make it cheaper. It's always make it cheaper.
Right.
Yeah.
Right.
Right. Yeah. It's like that's so basically you're right, Dave. That's sort of the spirit of, hey, tier one supplier, I've been buying this ABS module, for X amount of dollars, and it's been a great product. We're all really happy. We want to go around again. Same thing, but like not 20% of the cost out of it.
Right.
Yeah.
And and go.
Right. But make it like exactly the same, right, or even a little better. Why not?
Yeah. Well, actually should be better, right? And that's always the the purchasing guys, the automotives are like, well, I'm reading in the whatever the EDN or whatever the MIPS and stuff.
Right.
It's like, oh shit, and suddenly you're roped into, oh look, so you were making the ABS was running in a 100 millisecond loop before, and you should probably do it like a 50, right? Isn't that? It seems pretty easy.
Yeah, technology work design.
Yeah. So. Yeah, it's always sort of make it better, make it cheaper, but don't change anything.
Right.
And
well, going forward, I mean, we're kind of running out of time, but I'm curious about where you see electronics and cars going in the future. And obviously that doesn't include the infotainment side of things, but where do you see all this stuff going? And I mean, like I know in the U.S. at least, we're supposed to get to the 53.5 miles per gallon or some ridiculous standard coming up. And I don't know how that's going to happen. I'm guessing there's going to be electronics in there. Where's all this going?
Well, the big focus seems to be, there's really kind of four areas, right? It's the performance and the efficiency, and these are kind of the same, right? Or they're very tightly coupled. And then you've got the safety, and then just the whole complexity, right, of what's going on. And on the one hand, the performance and efficiency is kind of amazing, right? The internal combustion engine, it's like 100 years old or something like that, right? The concept, right?
It's not new.
And we've got more horsepower per kilogram or whatever than we've ever had before. We've got the control schemes are super sophisticated. The sensors and things like that. There's there aren't so many 200-year-old technologies that get improved, continue to improve, right? But but the efficiency is kind of what's driving stuff, big time in terms of the power, the powertrain electronics, and you've got different motivators in different regions, right? So, in North America, it's about, saving money so people aren't complaining about gas prices, right? Or, filling up the tank price, right? But in Europe, it's all about being green, right? And there's government subsidies and mandates and a whole web of that stuff that kind of shape how that stuff works. And so, you've got a whole set of drivers there that, technology drivers, right? So in terms of the efficiency, it's not even just attacking the engine itself, making it more efficient, but now I'm seeing that the electronic modules, like for example, you've got an electronic module in your door, right? It's got the little switches for the windows and stuff like that. Well, normally that's powered all the time, because, why not? You might hit the window switch, at random.
Yeah, I should watch for an action, right?
Yeah, it sits in a loop and it's sitting on some bus and blah blah blah. And well, guess what? They want to turn that off now in Europe.
Yeah, it could sleep, right?
Right. And and you think, my God, why? You're talking about something that's it's maybe drawing like 20 milliamps or something like that, or 30 milliamps.
Which is nothing for a car battery.
It's just to sell it, right?
You've got the engine running, that's nothing, right? But it's all about they're super motivated by the CO2 emissions, right? I mean that they've got such strength. Yep. So it's really interesting how these mandates really drive different different approaches, right? So definitely a lot of technology just being applied, or a lot of improvements being applied towards the performance and the efficiency.
And a lot of that comes with silicon updates too. I mean, smaller nodes and stuff like that. You get lower power in parts, and you do more with less parts and stuff too, right?
It's what it's not the processors that's sucking down all the current. It's all these. You're dealing with a bunch of sensors and actuators and
relays.
And, exactly. Yeah. And I mean, there's still a lot of relays, and to replace relays with solid state, I mean, my company would love to do that. That's we do that, right? That's
salivating.
That's fantastic, But what's nice about a relay is, if in one state it consumes no current at all in the coil. So
that's right.
That's right.
So it's.
Well, I was going to ask, how is all this complexity? It's getting more and more complex. All the electronics, all the everything. How is that driven the reliability of these things? Is it just getting harder, or have they had to lower the reliability
expected
lifetime standards?
No, it's just getting harder.
It's just getting harder, right?
It's the same stuff. In fact, there's more and more tests, all the time,
right.
And I mean, and it's really a big deal, right? Yeah,
of course.
Guess what?
Yeah.
The old half micron, quarter micron.
Yeah.
CMOS stuff, that stuff was pretty rugged. You could do all sorts of crazy stuff and it worked.
Right.
But now you're 65,
about
130. Yeah.
Putting a freaking ARM processor in the thing that, is down at, using a, 90 nanometer fab,
Yep. Yeah, exactly. And you've got and clock rates are higher, and they're all driven off of PLLs, and those have all sorts of interesting things they can do, injection locking and all sorts of fun stuff.
Yeah.
Oh, man.
It just boggles my mind. It really does, that they can get such complex systems to work in such a harsh environment for 10 plus years. It's, it really is difficult.
Maybe they don't,
Oh, well, maybe they just get lucky, right?
Maybe the fail-safe systems are good enough. Maybe you build backup systems just to watch everything now, right? And you have safe shutdown modes.
Right, exactly. There's a lot of emphasis on fail-safes and just, minimize, or really planning for failure, right? Designing for failure is really... key,
Well, you find that with a second-hand car, like you'll buy it and or a really old car, you'll find things start failing, but the engine still runs, right? The car still functions as a car, but
I can drive with the windows down.
You can't put your windows down anymore, or your radio doesn't work, or your or your mood lighting's died.
You gotta get out through the back passenger door, whatever. No big deal. Come on.
Yeah,
we've been in college.
But exactly. I remember that car.
It's not a problem until you're taking someone on a date. It's not a big deal.
Right.
Yeah, that's when. Yeah. Oh, yeah. But I think that's an interesting point, Dave, because you say, and I have the same view, right? But honestly, the cars that you and I are probably thinking of that are 20 years old, these are cars that the engine's mechanical.
Yeah.
Right. I mean, I'm kind of shuddering to think that what's going to happen when you got your, in about another
modern
10
cars
years.
in 20 years' time, will they be,
Well, or it's failed, and what do I do?
Yeah.
I mean, okay,
fine. It's so complicated.
I mean, well, fine. So the engine controller's dead. I need another one. Well, hell, we haven't made that part for 25 years.
Yeah,
right?
I know. You just can't do it. Yeah, you can't do it.
So basically your car is going to become bricked.
Right? Yeah, exactly.
Yeah, well, you'll probably see, though, is you'll probably just start seeing a market of people buying these modules and stockpiling them.
That's the only option.
You'll have a failure rate of 80% of just from age, but, some of them will still work, and they'll charge a crap load of money, and, you'll get a part. But
that increases the wastage because you have to dump X amount of cars now, sitting there doing nothing just to scrap the part, just to, rip all the parts out of it so you can get X number of good cars working, and you end up with all these chassis that are just stripped of.
You say chassis?
Chassis.
Chassis. You said chassis like SH, chassis.
Right.
That was an Aussie term. Yeah.
Yeah, it's sort of an organ harvesting operation.
Right? Yeah, exactly. That's it.
So suddenly your 1987 Buick wakes up in a bathtub packed in ice missing a kidney, right? Because it's like, oh, I guess somebody needed an engine controller.
Yeah, well,
yeah,
for the greater good.
Yeah, well, they might be stealing cars, not to sell them as cars, but to strip all the parts, the valuable modules out of them, right?
To get those MOSFETs out of there, whatever they need.
And they don't even have to steal the car. All they got to do is climb under and disconnect it, and just slide under your car with some screwdrivers and disconnect your module.
Well, and that happens even just for body parts, right? I mean, I've a friend of mine. He's had an older car, and he's had the it's sort of the tail light assembly, stolen out of his car twice.
Right, yeah.
Probably by the same guy, right? Because and I'm like, well, why the hell? That's just bizarre, right? He's like, I know why they stole it, because I had to find this one, and it cost me, $200 to find it.
It's probably the guy who sold it to him. He's like,
probably
I'm going to sell this again. Another $200.
Write your address down here.
Yep.
Yeah. So that,
and you go back the next day. Oh yeah, I've got another one, mate. I'll sell it to you.
Yeah, fresh. I got it in fresh.
Oh boy, I've got to ask. With the electronics, does any of them get potted with like potting compound to help with like vibration or anything like that, or are they just non-potted?
Some do, but it's avoided, right?
What would be the criteria for potting an automotive module?
Right. So you can see potting, for example, in some of the engine-mounted assemblies of the modules there.
Yeah.
Because they're the vibrations crazy.
They're the vibration killers. Yeah.
Right.
And dirt too, right? I mean, dirt's a big deal around there.
Yeah. Well, I mean, honestly, but at that point, you're probably like in some die-cast aluminum box, and you've got gaskets and all sorts of stuff. Those. I mean, if you're in the underhood, you're serious, right? You're
right.
You got your game on as far as environmental stuff.
So those guys, do you walk by those guys at the company and you're like, ooh, the badasses?
They're the potting people.
Exactly.
Well, potting is such a disaster in production, though, right? It takes.
It's horrible.
I mean, this one I know because one of the products that's been near and dear to my for the last few years has been the little tire monitors that go in your tires.
Oh yeah,
those things suck.
Yes, they do suck. Yes, I'm sorry.
No, that's okay. Yeah, because those are all RF, right? I mean,
they're
those
all
talk
RF.
to
So they're powered off a battery. And those are potted, right? Because the tire is evil as far as this environment. I mean, like, hey, here's what I learned. They use sulfur during the vulcanization process of making the rubber.
Yeah.
And then you put in your...
In Akron, Ohio.
And then you put in... Yeah, exactly. And in Dave State. And then you put in your kind of wet, moisty air when you're filling the tire, and then it gets cold, and then the water condenses, and then the water and the sulfur mix up, and you've got sulfuric acid, and it's...
nice.
Wow, I didn't know about that. So
Oops.
So
guess I'll pull out my chemistry book.
Right,
huh?
Yeah, I'm not a good chemist. So and so those are potted. But honestly, I mean that one, I just know that it just adds hours to your to your manufacturing cycle time, right?
No, it's terrible.
Yeah, it's just God, what a mess.
Avoid at all costs.
Yeah. So exactly. So when are they potted? When they have to be. Only.
Exactly.
Yeah.
We're way over time, Chris.
Tom, any last words?
Wow, time flies.
No, I know.
Well, hey, thanks for having me on. It's been a pleasure, and hopefully I've opened a few doors and opened some cracks and let people see the weirdness that goes on in the automotive land, huh?
You have. Yeah. Thank you very much.
Yeah, thanks for being on. Tom, do you have like a Twitter account or anything? Could people reach you on there, or how do people find you if they want to find you?
You know, I'm old. I just have like email.
Email. Okay. So if people want to really get in touch with Tom, get in touch with us on Twitter.
And he'll sell you some parts.
Yeah, maybe.
What's it going to take to get you in a new part today, right?
Yes. You look like you need some silicon.
Psst, hey, buddy. He's got a trench coat.
Yeah. You want to buy a chip for an automotive grade?
Exactly. I got this trench coat. It's got all sorts of MOSFETs and stuff hanging in it. It's great.
All right, well, you can find us on Twitter at The Amp Hour, or me and Dave at Chris_Gamble, Dave at EEVblog, and you can find Tom hopefully in the comments section or by email if you want to really talk to him.
Hang on, we've got some news we wanted to add because it's time sensitive.
Oh, that's
Sorry,
true.
Dude.
Yeah.
You wanted me to add it. Quick.
Yeah. Okay, so Lemnos Labs is there's another. We talked about the Hexcelerator program on here. We told people about the day or two before, and actually someone ended up going to that. We thought people might like that again. So they're Lemnos Labs. We'll put it in the show notes, but they've got a deadline coming up for 2 weeks. It's another hardware accelerator program. So if you got an idea, you can go there. If you're working on automotive electronics, you can give Tom a call and get a bunch of free parts.
All the MOSFETs you can eat.
Yep. Well, thanks so much for being on the show today, Tom.
Thanks. It's been a pleasure, guys.
Catch you all next week.
See ya.